Negative exponents make some of us have blurred vision, dizzy spells, and sometimes nausea. But not today. Let me just bring this to life to you just a little bit. I'm going to show you a couple of techniques on how to just make negative exponents make just a little more sense and just how you get to them. They show up the most with division, to be honest. That's, to me, where I think the foundation comes from, is why on earth are they here? How did we get to them? Why do they exist? If I'm dividing 5 to the third and 5 to the fifth, one of the things that's going to stand out to you right away is the 3 on the numerator is smaller than the 5 on the denominator. We know in fraction world that typically means your number is less than 1, so it's going to be a really small number, and that's okay. I'm going to show you 2 techniques to get us a better understanding of negative exponents. So we have 2 ways we can approach exponents. We have the law of exponents, which says if we have like bases, we can subtract our exponents. So let's do that. So we know that 5 is our base, and we just take 3 minus 5. And if your integer subtraction is not rusty, you know that 3 minus 5 is negative 2. And at this point, we're like, wow, look at that. That is a negative exponent. That looks really uncomfortable. What on earth does that even mean? And what does it represent? Let's do this in a different approach. What if I expanded it, used my favorite math hack, a cancel party, and then I just left it in a fraction form? Check this out. So I'm going to convert this. This is 5 times 5 times 5 on the numerator. The denominator, there are 5 of them. Okay, calling all party animals to the cancel party. Please join me. Cancel, 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 cancel. Okay, now once again, something I always like to come back to. Just because they're canceling doesn't mean everything disappears on the numerator. It's a common error because then you feel like your answer is just going to be 25. And you and I both know that if 25 is on the denominator, that is not the same as 25 on the numerator. So let's give ourselves some ones just to remind ourselves that we have 1 on the numerator. And then let's leave this in exponential form. This is 5 squared. Now look at these 2 together. We have 5 to the negative 2 and 1 over 5 squared. These mean the same thing. We just proved it. It's the same exact thing. Let's go one step further. This is 1 over 25. So 1/25. That's a teeny, teeny, tiny number, right? So if we were to put this in decimal form, which is something, completely different, that would be 0.04. So then we think, that seems really tiny, and it is. So once we have these worked out, we can see that a negative exponent and a fraction, they have a relationship there. So let me remove the decimal here for just a second. A couple things to also just appreciate is if I were to ask you to convert 4 to the negative second to a fraction or a positive exponent, we can see here, and actually let me erase this one too. Check this out. Let's go all the way back to this little comparison here. You can see a little connection here. We have 5 to the negative second, which is the same thing as 1 over 5 to the positive second. So in order to create a negative exponent and turn it into a positive exponent, it's going to have to transform into a fraction. So this is going to turn into 1 over 4 to the positive 2. So if you just look at these 2, without me going through all of the explanation again, you can get to the point where you can convert them very quickly back and forth. And then it just becomes a little easier once you remember how you got there in the first place, and then how we can get here without having to do all of this prep work every single time. So negative exponents hopefully revealed and made a little less confusing.